Hello, everyone. Okay, so this week in game hacking has been pretty eventful for our first week. If you're not quite as far along as I am, that's perfectly fine. All you were expected to do this week is do the introduction and complete the Goodness Gracious quest, but I have moved forward into week 2 material here because I'm attempting something a little bit different this semester. So the first thing I forgot to mention before, I want to make sure that it's very clear. You are expected in this course to use outside materials. There's lots of write-ups that are done for Pwn Adventure 3, plenty of them out there. Live Overflow has a very good series on YouTube, which I do recommend you watch. I have linked that in learning resources. I've also linked the Guided Game Hacking Bible, which is an excellent resource for this, as long as I think they might have closed that source. And in the process of writing my own DLL hook, I did my own research, of course, as well, and I came across a very excellent write-up that really explained the process and really walked you through it. Jai Minton posted their own write-up to their own site. I'm going to pull it over here for you. So I want to make sure I give credit where it's due. This person here, Jai Minton, they did their own walkthrough here for Pwn Adventure 3. This is their whole write-up. They have tons of information here about the game and what they went through in their process of hacking it, but that's all perfectly fine. Go ahead and use whatever sources are out there. That's part of the course. Nobody here is reinventing the wheel in this industry. I mean, you shouldn't take anything wholesale. You should certainly also give credit where credit is due, because so many people post solutions because they wanted to figure it out and then they wanted to share it, and you really ought to give them credit when they do that, but it's okay to use it. In this case, with them as a guide. Oh, and I also linked Antonin Bourgeon, is another person who did Pwn Adventure 3 work that has a repo on GitHub. Also, that's a good resource. I'll make sure to add that link to Canvas here. But anyway, using that as a guide, I was able to create my own DLL hook here. I'm just going to walk through it and show you all the parts. I know that I posted a montage of writing it, but of course I didn't explain anything, so I don't really expect you to have paused the video or whatever to see what I'm doing. That's what this video is for. So let's go piece by piece here. All right, so I began by opening up Visual Studio here and starting a new, let me actually show you what I did. New project. You might need to get the C++. You might need to add that language here. But if you do, there is a C++ DLL template. So I just started one of those, and that gave me the DLL main, and I think that's, and I think and include, that was about it. So this DLL main entry here, all that is basically just little, code sections. You can add your own calls here. And so what I wanted to do is when the DLL was injected into the running game process, it would create a new thread and call Pwn hook. So there's a Pwn hook function in here that will be called when the DLL is attached, creates a thread, and runs the Pwn hook function in that thread. So that's all this is. This right here is the only line that I added to the default DLL main template. So now what I want Pwn hook to do is I want it to essentially sit there in the background after injected and wait for key inputs, and depending on the key that's inputted, to make adjustments to either various different addresses, values held in addresses in memory, or make other modifications to the running game. So we'll go up here to the I guess we'll start at the Pwn hook module, because this is what's called. So here is the main function here for my cheat, my trainer. I know right now that there's at least 2 hacks that I want. I want a speed hack and I want a fly hack. I want to do the speed hack first, because that seemed a lot more reasonable, a little bit easier of a place to start. So because I know I want to, and I know I want to turn them off and on, of course I'm going to need a couple of bools. So here's the bools that are default false. So when we start the game, they default to false because the fly hack obviously is not on. We want that flipped to true when I do turn it on. So I need to pick which key I want associated with the speed hack. So down here is the actual code for the hacks. And I chose the get async key state when I press F1. That will be my speed hack button. So the first thing we do is we flip that bool from false to true because we just turned it on. And then we do a check. If speed hack is on, as we just turned it on, then patch this memory address. Now patch is another function. So let's go up to patch and see what that does. That's right here. So here's void patch. It it finds the old value. Old value is the value of that. Okay, so what we need to do if we're going to be writing areas of memory is our areas of memory have ACLs, right? So there's going to be entitlements that are associated with them. We need to change them so that we can read write. Then we can mem copy in the new value, and then we can restore the old entitlements to that particular area of memory. That's all patch does. So it finds the current entitlements, changes them, modifies that memory address, and then changes them back. That's all it does. Okay. So we patch that, and this is the address we need to patch. This was the hardest part of doing the speed hack because I only just started digging into the game's code again, and I don't know it by heart. So I had to look around and figure out where is the value for the speed multiplier. So let me go back to Ghidra. If you watched the montage at the end of the last video, you know that I spent some time looking around, trying to figure out where this value was. I had actually found it earlier. I was just looking for a better way to do it. So actually, let me not do the search. So here I am in the player class. Okay. What I did is I started the game. I attached Cheat Engine to the process. All right, here's Cheat Engine. And I wanted to know what the memory offset was for game logic. Because, of course, when you attach Cheat Engine to the process, you're attaching it to the client. So the actual Pwn Adventure 3 binary. The Pwn Adventure 3 binary loads gamelogic.dll. So I don't know where in memory either of those things are loaded, but I need to know where game logic is if I'm going to modify it. So I added manually a memory address, and that memory address was, quote, gamelogic.dll. And that gave me an address. That address, the last time I ran the game anyway, was 7AA20000. So I went into Ghidra, I clicked the memory button up here, and then I clicked the home button, and I rehomed GameLogic DLL to that first offset. And basically what that does is it changes these memory offsets to all be relative to that address. So basically, I know Ghidra is now telling me where in memory these code segments can be found, right? The top, this first address here in GameLogic DLL will be 7AA200000. That's exactly what it will be, which means that player get jump hold time, this function, can be found in the active memory of the running process at 7AA6FFBO at that offset. But if I'm doing speed hacking, what I need to find is the value for the run speed. So if we do get sprint multiplier that we found before, get sprint multiplier is also attached to this whatever cooldown. I'm not sure that Ghidra is actually interpreting this correctly. I don't know what the deal is with this. But in any event, get sprint multiplier is somehow associated with this and this value, which is 3. And down here is the assembly instructions for that. So here's C3. This is the return. What value is being returned? It would be this, right? This D word pointer. at 4040000. What do you suppose that represents? Let me get my hex calculator up. What do you suppose 4040 represents here in these assembly instructions? If I go here, convert, we'll convert it to a decimal, sure. 4040. Oh wait, no, I want hex to float. That's a float, not an int. Hex value 4040 converts to the float value. Oh, hold on, that's wrong. 40400000. There we go. That converts to the float value 3.0. So this value is this 3.0. And all we're returning is this value. Okay, well, that's fantastic. That means we need to change this. We need to change this on the fly. So when we hit our F1 button, we want to change this from 4040 to whatever our float value is. And then when we hit F1 again, we want to change it back to 4040 or 3.0. So we know that our... hold on, where'd my calculator go? Let me go back to that hex calculator we saw before. Here we go. So we know that according to Cheat Engine, that a game logic DLL, the top of that is 7AA20000. Right, that's the top of game logic DLL. We rehome that in Ghidra, so we know that this value, if we double click that, can be found stored in this address. So 7AA, oops, minus 7AA 98B34. That's where that 3.0 value, the 4040, that's where that's going to be stored, or that's where that is stored in memory in the running process. So if we calculate that offset, we see, well, I did the operation backwards. It should be the larger number minus smaller number, but whatever, it's fine. This is the memory offset. This value can always be found at game logic DLL offset plus 78B34. So if we go back in the code, that's all I did. Patch, locate memory address at module base, which module base is figured out up here, which is the get module base address for the process ID, and then game logic DLL. The get current process ID is located here with get current process ID. So current process ID, that address will be the top of the game client, and then get module base address is that process, but we're looking for quote game logic DLL. So that gives us whatever that module is. Then we add 78B34. That will always be the memory address for the speed multiplier. So when we click the button, we flip the bool for speed hack from false to true, and then we patch that memory address with whatever speed is. And I defined speed as 15. So 5 times faster than the default speed. I can change that to whatever I want. I just figured 5 times faster was good enough. If I hit F1 again, then speed hack is toggled from true to false. Our else statement kicks in, and that's just another patch. But instead of patching our 15 value, we want to patch back to 3. And what I do is I could just say 3, but instead what I do is when the process, the DLL is attached, I go ahead and get the value that's currently in module base offset plus 78B34. So whatever the default value is when I log into the game. I probably made it more complicated than it needs to be, but I figured I would grab the value, and then if the value for some reason were to change for whatever reason, then I wouldn't need to worry about it. I overthought it. I should have probably just used 3.0 and just left it at that, but whatever, it works. One thing I figured out in testing is that you need to have a sleep here. Otherwise, it recognizes the keyboard input way too fast, and you just toggle on, off, on, off, on, off, on, off. So you need to have a sleep there to give you time to take your finger off the key before it retoggles it. For our fly hack, that's going to be my next step, which I will do in the next video. I'll go through the process beginning to end of finding how to find the value for the let me show you the angle I'm working anyway. There is a get jump hold time here. This does not have a static value in it. This, like get walk speed, is just the Z value for remote look position. So I'm looking for that value. There's got to be somewhere. There has to be a jump hold time value. I just don't know where it is yet. So I'm looking around for it in the code. When I find it, I'll record another video showing where I found it and then how I do the calculation, and then I will in real time write the code segments for the next hack. But right now, this is where, when I press F2 is when I'm going to turn my fly hack on and off, and right now I just have nothing. Oh yeah, that's one other thing here. There is a code segment here for a console. I just wanted a console to so I could see that it's working. That's totally optional. Technically, we don't need it. I just wanted some feedback, so I all of this is output to a console to let me know when things are on and off and all of that, so I can figure that out. So the next thing I did, let's see, well, did I cover everything? Oh, get module base address. Yeah, this one I didn't cover yet. Get module base address is where I call this for getting game logic DLL. So let me show you what that does. So get module base address here uses create tool help 32 snapshot in order to grab our process ID and basically read the areas of memory that we have here, just like Cheat Engine is doing now. This is just the code that replicates that, so that I can refer to quote-unquote game logic DLL and get the base address for that entire module. That's really all it does. This information is all available. This is Jai Minton. One of the things I really like about his write-up is that he links to all of his sources. It was really nice for me to be able to just go right to the documentation. So if you want to know how create thread works, do what I did, read the create thread function documentation. If you want to know how I'm getting the base address, you go to that documentation right here, create tool help 32 snapshot function. It tells you everything you need to know about how it works. So that's just how we get that address to begin with. And that's it. It's really as simple as that. I do have this. Oh, I'm sorry. I was just about to get to my next point. So the next mistake I made, of course, is that I was in Visual Studio. I started a DLL project, and then when I built it, I forgot that this is a 32-bit application. Pwn Adventure 3 is 32-bit, not 64. So if you get an error that kernel 32 DLL couldn't be found or whatever, it's because you compiled for the wrong architecture. Go back and compile for 32-bit and you'll be just fine. If you don't know how to do that, well, I'm sure everyone here is familiar enough with Visual Studio, and if you're not, then I'll leave it to you. Just search it. That's what I did when I made that mistake. And I should also warn you, anyone in this class that is a programmer, obviously what I've just shown you is probably the worst thing you've ever seen. I am not a programmer, okay? I work in cybersecurity, I hack together solutions, and spaghetti code is where I live. All of this is based off of writing as I go, figuring out what I need to do next, looking up what I need to do next, and of course relying on write-ups written by people that are way smarter than me in order to cobble my way through. But at the end of the day, I have a working internal cheat. Let me end the video here by showing you in real time and explaining the entire process for getting this thing working. All right, so here I am. I'm in the game, and I have my cheat engine attached to the process. I kept the list. You can save lists of memory address in Cheat Engine. That's what I did. So since I didn't close it, I still have the list. But note that GameLogic DLL is no longer at 7AA 20,000. It's now homed at 79B 40,000. That's because we have ASLR. This is a position independent executable that's going to change, potentially every time the program runs. So that's why it's really important for us to be able to find this memory address, because we don't know what the base address is going to be every time it runs. We can't just use that hard-coded value because it might be different. In this case, it certainly is. But when I located the speed multiplier in Cheat Engine, I tested this to see if I had the correct pointer by adding this as a memory address for GameLogic DLL plus the offset that I found. And I know that if I start Cheat Engine and this value is 3, I know that that offset's correct because that's the float value for our default speed multiplier. So right here, this float right here for speed multi, this one is that calculated address. This is where in memory, I can even show you in Ghidra. There, get sprint multiplier. This Ghidra is rehomed to my old base address for GameLogic DLL. And this address, sorry, this address is our speed multiplier that we just saw. So this is that address. And look, because it's been rehomed, because we're no longer, GameLogic DLL is no longer at the old address, this value is no longer related to our speed multiplier. This has got something else in it. We don't even know what the hell is in it. It's just question marks. So this is why it's important to do everything relative to the base address. So we are good to go. Our cheat should still work because we wrote it to be relative to that position. All right, so now I'm going to do our DLL injection and get our cheats started. I'm going to go to memory view. All right, so here we are at whatever address this happens to be. Doesn't matter. I'm going to go to tools, inject DLL. I have moved PwnHook DLL, the compiled version of that DLL code that you saw. I moved that into my Pwn Adventure 3 folder so that I could easily find it and kind of do version control. So this is should be the version that I last built, if I remember correctly. Now it asks, do you want to execute a function of the DLL? Yes, I do. And DLL is injected. And here's the console window that I asked them to start. This is the output that I requested. So PwnHook 1.0 injection successful. This is the PID for our client. Here is the base address that we're working with. This is the jump height. That's currently not working. So whatever value that is, I don't know. But here's our current speed, which is 3. And that's our default speed. I'm going to move this over off to the side. And I'm going to move my game client over here so that we can see it while we are working. So here I am in the game. My speed is 3. When I press F1, our speed multiplier should go from 3 to 15, and I should move 5 times faster than I am right now. So while I'm moving, I press F1, speed hack is on. It sure is. I'm definitely moving much faster. Now the default speed hack with Cheat Engine, as we saw last time, I don't think that actually changes the speed multiplier. I think that changes the clock because the bears were acting weird. I think it's just running the game 5 times faster when we use the speed hack that's built into Cheat Engine. Let's see if we can find some bears and see if they're operating more normally. Yeah, with our speed hacks. Yeah, they're fine. So yeah, the default speed hack does make you move faster, but that's because it makes everything faster, and that's certainly not something that we want. So now I can zoom from place to place, and I can press F1 when I want to turn it off, and I can press it again when I want it back on. So now I don't have to worry about flying across the map and then missing my place. All right, so I'm going to get to work now trying to find the fly hack ability, because that would be super nice to be able to jump on top of these buildings or whatever before we get on to our first actual mission. So when I find that, I will start the next video. I will explain how I found it and walk through the process of adding it to our internal hack, our trainer. And after that, right now, the code that I just showed you, that CPP file, that is on Canvas. Feel free to use it. It only contains a working speed hack. It does not contain a fly hack. I will not update it with the fly hack. I will show you in the video. You will have to add it yourself if you want it. And if you want to continue using it for the rest of the cheats, the rest of the missions, then you are going to have to figure out how to add to it yourself. Use the resources that I provided you, but that will be your next step. You don't have to use it, and it's not going to solve all of the problems, all of the missions for you, but we'll get to that as we get to it, okay? But I'm sharing the beginning with you. I'm sharing with you a working speed hack. You can figure out the rest. Next video, I'll at least show you how I get a fly hack working, and we'll go through it together in real time so that you can add it yourself, and then after that, you're on your own, okay? So we'll see you in the next one.